Here we have a Gigabyte RTX 3090 that came in for no power. And I hate working on Gigabyte cards because success rate is low. We already have the board disassembled right here. And we're gonna take a look and see if we can figure this out or what's wrong with the card. Let's go under the microscope. And we can see that we have 3 power inputs on the top, 12 volts, 12 volts, 12 volts. And under those connectors, we have 3 coils. Each coil is for one of the power connectors up there. The first thing I want to do is check for 12 volts on those 12 volt rails. We're going to put the meter in diode mode. And we're going to measure this 12 volt coil, and we don't have a short. 0.45 voltage drop, which is perfect. 0.46 voltage drop. And where's the third coil? Right here. And we should have the same reading. Short. Wow, we have a short circuit. We already know what the problem is with the card. It does not make sense to troubleshoot anything else on the card because we have a short on the 12 volt line. If we do not have 12 volts, we're not going to have 5 volts, we're not going to have 1.8 volts, we're not going to have memory, we're not going to have packs, nothing. We have to take care of 12 volts before we do anything else. What is causing the short on this 12 volt rail? That's a very good question. Usually, from my experience working on those cards, it's a MOSFET that causes a short. And it could be that a MOSFET is bad, or the MOSFET may have sent a higher voltage to the GPU than what the GPU can handle and fry the GPU. So let's say we have a bad MOSFET. Replacing the MOSFET is not guaranteed to fix this card because we may have a dead GPU. So let's see what's causing the short. Let's try to figure out what's causing the short. We're going to use our thermal camera, but I can tell you, even with the thermal camera, it's very hard to pinpoint where the problem is because very little heat gets generated by the short to a point where it's very difficult to see which MOSFET is the problem. The board is very thick and absorbs a lot of heat. Let me do a quick visual inspection on the MOSFETs just to see if there's anything obvious. Maybe a blown MOSFET, or maybe burnt flux around the MOSFET, or something unusual. We have more MOSFETs here. These are DR MOSFET and driver. I call them MOSFETs for the sake of simplicity, and some people complain they're not called MOSFETs. Congratulations, you're a genius. But we're gonna call them MOSFETs today. Let's get our thermal camera ready. Let's focus on the first row of MOSFETs that we have here. And I'm currently at 1.3 volts. We're gonna inject 1.3 volts, but from experience, I know 1.3 volts is not gonna do anything, and we're not gonna be able to see the heat spot. We're gonna have to bump up the voltage. We inject for a second and then we take it out so we can spot the heat. 1, 2, and 3. Inject voltage, and the current being drawn is 2.2, and we do not see anything hot on the board. And if we check the column of MOSFETs here, no heat spots at all. We're gonna have to bump up voltage. I know this from working on those cards many times. 1.3 is too low. It's recommended to start below 1, but not when you are working with this card. Let's go up to 1.9. And 1.9 is gonna kill the GPU. No, it's not. And let's inject voltage again. And still nothing is obvious, even though the GPU is a bit warm, but nothing is obvious. I'm gonna bump up voltage just a tiny bit more. So we go in increments of 0.2, 0.2, 0.2. We just want to barely see where heat is coming from. Oh, got it. See it? Right there, somewhere right here. Watch. See it? Right there, right there. You can just barely see it. Barely. Got it. And look, the GPU got a bit warm because we increased voltage by 0.2 increments. But I did not keep voltage on the coil for a long time, just a split second, just to see where that heat spot is and remove. We got it. And I know exactly where the heat is coming from. Let's go under the microscope and hopefully that fixes the problem. Heat is coming from the third MOSFET from the top. So 1, 2, and 3, right there. Heat is coming from here. Now we need to desolder this DR MOS, but the problem is we have aluminum capacitors on the right side, and those capacitors do not like heat. If we apply heat on here, this cap may blow, or the one next to it, or the one next to it, and we do not want that to happen. So we're gonna have to cover those caps with a heat sink or something so that when we apply heat, they're not affected. And I have a piece of heat sink with thermal pads under it that I often use for this purpose. But now that I need it, I'm not gonna find it, of course. Why would I find it when I need it? Oh, right there, right there. It was hiding. Okay, so I just rotated the board and MOSFET 1, 2, and 3. We're gonna remove this MOSFET right here. And why not use my goggles just for safety? I use goggles anytime I'm working with components that are next to aluminum capacitors, just for safety. So again, this is the Gigabyte 3090. If there's a short on the 12 volt rail, then the video card is not going to power on, and possibly the whole computer is not going to power on. I'm using a narrow nozzle, so I need to change the hot air nozzle. I mean, that board is thick, and soldering any component on that board is difficult because it takes a lot of heat. The board will absorb all the heat before it reaches melting temperature of solder, and that's when you will be able to remove or solder components on the board. Right now I'm at 500 degrees Celsius. And we're gonna have to keep constant heat on this area, and I'm just worried about the aluminum capacitor. We have it covered, but still. So we have to be out as soon as possible, like we did now. Now the next time, it's not gonna take a lot of heat like now because we're gonna apply leaded solder, and leaded solder melts at a much lower temperature than unleaded. The chip name is AL00. Now if you look at the layout of the chip, it looks just like the NCP chip that we sell on our site, which is used on laptops and some video cards. But AL00 is not the same as the NCP chip. Even though the layout is the same, there's a 1-pin difference, which is the temperature sensor. This one here, AL00, is the same one as the BLN0, which is very popular on video cards. I have a donor video card here next to me. Let's take a look. And this video card is using the BLN0, which is the same chip as the AL00, unlike the NCP, which has a different pin layout. Let's go over the data sheet between the BLN0 and AL00, just to make sure that we have the same chip. So one of them is the AOZ 5311N, and the other one is AOZ 5332QI. If we look at the difference between both chips, the BLN0 and AL00, let's look at the chip layout. You will notice that it's exactly the same chip. You see pin 31 and pin 30, how on pin 30 we have THWN, and that's the temperature sensor. On the NCP chips that we sell, pin 30 is actually pin 31, and pin 31 is pin 30, so that chip will not work. But if you look at AL00 and BLN0, they are exactly the same. All right, you can pause the video and look at the chip, or you can just go online and research the chips. But for now, let's go ahead and replace the chip. We're gonna have to tin those pads, add some solder. And then we're gonna grab the BLN0 chip from our donor card. And we have a shipment for those chips that will be coming in very soon. All right, so let's do it. Add some solder, and we're gonna just go like this. And the pins on the bottom are all connected as one, so it's okay if they bridge. Just add some solder here and some solder here. Just want to make sure we have enough solder on all the pins, and those pins are connecting with each other, so it's okay if they bridge. And those pins are connecting with each other. Again, it's okay if they bridge. Let me go over the diagram one more time. You can tell that pin 16 to pin 23 are all connecting as one pin. Pin 24, 25, 26, one pin. And then you have VN, 9, 10, 11. And then you have 12, 13, 14, 15 are all connecting as one pin. And what that calculates to is those pins are one, those pins are one, the three bottom ones are one, and that's how it goes. Let's grab our donor board, extract that component from BLN0. And the chip is out. The board is burning hot. You cannot touch it. So just imagine the whole board had to reach melting temperature of solder in order for us to be able to remove that chip. Not the whole board, but at least a big portion of the board where we are applying heat. I got the chip, and before I lose it or before it snaps, let's put it here. And pin number 1 should be like this. So once again, let's cover those aluminum capacitors. Goggles on, and we're gonna solder that chip. But you know what I did not do? I did not test if our short is gone or not. I just assumed that we had a problem here, and I did not even measure if the short is gone after we removed that chip. Wow. Let's go ahead and measure now. I'm almost positive that our short is gone, but we're gonna have to measure. Just imagine we still have a short. Meter in diode mode. And are we gonna hear a continuous beep, or? You see, I told you, 0.44 voltage drop. So we got to the faulty component exactly. We did not play around. No time for playing games. We got straight to the faulty component, took it out, and the short is gone. Magic. That's called magic. Let's get rid of that blob. And right now, if we measure, just to make sure that we do not have a short after we solder that chip, what do we get? 0.43. Awesome, amazing. All we have to do is try out the video card, and if we see an image on the screen, the job is done. We can benchmark it later, make sure everything is working, but right now all I want to see is an image on the screen, and we'll end the video. All right, so let's install the video card. Just like that. We plugged in one power cable, and we need to do the second and the third. And that's another one, and we need one more. That's a very powerful card, and it's power hungry. You know, like that monster that has to feed on people in order to stay powerful. It's the same exact thing with this card. Okay, and that's the third cable. And right now, for safety, I want to wear my goggles. I have a good feeling that the card will work. HDMI cable. And let's see. Ready? 1, 2, and 3. Take my shades out, the keys, and we want to look here. The fan is on. We do not see any smoke. We do not hear 6 beeps, and that's a good thing. Not hearing 6 beeps is a good thing. It means the card is functional. But I do not see anything on the screen. The board is hot. Okay, let's turn it off. And turn the monitor on. The monitor was off. I think there's something wrong with the HDMI cable because the cable was loose from back of the monitor. I put it back, but maybe the cable was bent from the back. The motherboard is on. We do not hear 6 beeps, and that's good. Okay, let me grab another HDMI cable. I'll be back. Hello, hello. Let's try this one more time. The board is on. Yes, yes, right there. The card is working. So it was the HDMI cable. Because the cable was bent from the back, it looks like the screen tipped over and it damaged that cable. Right now the heatsink is not on, so the video card is gonna shut off by itself, but the card is working. We did it. We saved a Gigabyte 3090 from the landfill. Awesome. I'm gonna give this to Big Boss to reassemble, and he's gonna test it for about 20 minutes. And then we're gonna invoice and mail it back to the customer. That's it. I hope you enjoyed this video. Don't forget to like and subscribe. Let me know what you think, and I'll see you again in the next video.